Hey guys, good morning, or whatever day it is, time of the day you're watching this video. Anyway, these are the notes for section 5.3, which is about polynomial division. I'm probably going to break it up into two videos, one dealing with dividing with a monomial and the second dividing with a polynomial. So these are mechanical things that we have to do in math like every day whenever you're doing any kind of mathematics. I've written in here some notes on how to do stuff. The first topic is monomial division. A problem would look like, okay, hang on just a second. My marker is not working. So why? Let's find out. Oh, I know why. There, now we should work. Yeah, we're good. All right. Sometimes you know how it is. Okay, so monomial division, looks like a problem. I'll just say right now, it looks like a problem like this example number 3 that I work out all the way for you. And I go to the trouble of showing you guys that when you are doing polynomial arithmetic, we're mimicking what we do in arithmetic. So studying these examples here are helpful. So let's look at them again. So what I'm writing is 3 over 14. When you add to that, say 6 over 14, okay, you have what they call a common denominator, remember? So you add how many 14ths? 3 14ths and 6 14ths is a total of 9 14ths, okay, big deal. You have to add like fractions and all that stuff. Well, if we focus on this portion of it right here and look that way, that is to say, if I've got a fraction that's got a sum or a difference in the numerator, okay, sum or difference in the numerator, we can split it up into 2 fractions or more, depends on how many you're looking at. So that has to be a sum or difference this is really important to say, in the numerator. Don't think of it in the denominator, just the numerator. And people in calculus do that all the time. Like, oops, it's a mistake. So what's the point? The point is that you can actually write it in this direction. And the same thing goes with this particular example here. It is a polynomial on top, 4 terms, and it's got a monomial downstairs. And that's what they mean by monomial division. You're dividing a polynomial by a monomial, okay? So dividing a polynomial by a monomial, a single term polynomial. And we were doing some of the exercises yesterday in class and just going through them and showing how things reduce. The point is this: you split it up into so-called baby fractions. Okay, and when you do that, after you do that, you reduce. You reduce each fraction. And I'll do examples, but here you can see 15 over 3 is really just 5. And then the x5 over x2, subtract the powers. Each one of these guys is reduced individually. And that's how you do the math. This guy, this guy, this guy. And that's your answer. I know it's kind of crowded. So let's look at another example. So those of you that like a laundry list of how to do it, and I don't blame you, it's right here. Here's how you do it. You split it apart. What you do is you split up the fraction into baby fractions, then reduce each baby fraction until you're done. All right, so looking at this example, we'll do it. So someone says on the test, like maybe Weber says, divide this. Okay, typical problem. What you do then is you just write, okay, 8x squared y squared divided by 2y squared minus 10x y cubed. You get the point, right? Every time I write it, it's 2y squared downstairs. This is a minus again, huh? So it's a minus 5y over 2y squared. That's your first step. The last step is to reduce. So I'll do that in red. I'll go, this time 2 goes into 8 4 times. So I write a line, I put a 4 here and a 1 here. Why not? Nothing happens to the x's, so I just write x squared, because there's no x downstairs. What happens with the y squareds? Well, if they're exactly identical, they cancel. So this is what we have for the first fraction. Moving on. Okay, draw another line, do another cancellation. This time it's 5 over 1. I put the 1 there to remind me there's got to be something down there. Again, the x's are not canceling, so just x. And this time what happens is the y squared takes away 2 from upstairs, leaving 1, and there's your next answer. That's your next fraction. Finally, line 5 over 2, nothing reduces there, so just write 5 over 2. And this time the y's are more plentiful downstairs, so you lose this guy, he cancels with one of them downstairs, and you're looking at your answer. Okay? If you want to write it nicer, it would look like, well, I would write maybe equals 4x squared minus 5xy minus 5 over 2y, and that's it. Remember the stuff from 1.5? Excuse me. That's helping me cancel all this stuff. The quotient rule and all that stuff just helps me do it. With enough practice, you go, this is not so terrible. Okay? All right. So that's an example. What I would suggest you do is pause it and try these two. Okay? And then the next step is long division. So go ahead and try it. Go ahead and pause it right now. Okay, and I'm going to keep talking. So anytime you want to pause it, go ahead and work on it. But now I'm going to start working on it, okay? So what you should have done is written this as 14y5 over 7y4. I think I took these out of the book. 21y squared over 7y4. And we cancel. Now we write equals. I don't know why that happened. I'm going to have to. Sometimes that happens. I push something. Okay, so a line. 14 and 7, that's 2 over 1. So we write 2 over 1. And what happens with the y's? Well, the guy upstairs, there's one more than downstairs. So the y4 cancels, leaving just 1 left over upstairs. All right, we'll clean it up. Plus another fraction. This time 7 goes into 21 3 times, so we get 3 over 1. And this time the y's downstairs are more plentiful, so you lose these 2, and you end up with a y2 downstairs. Okay, so we write our final answer, 2y plus 3 over y squared, and we are dividing with monomials. This is how it's done. All right, the next one. You should write 4x to the 5th over 4x cubed, etc. There's a lot here. You know, I've done this quite a bit in different areas of mathematics. It's just, you know, the tedium of doing it. But it leads to great answers, you know, stuff that you can do in mathematics. All right, so we're going to reduce. This time the 4's completely cancel. If you want, you can write 1 over 1 to keep a placeholder. We don't really have to. You can see x3 canceling with 3 of them, leaving 2 upstairs. So really, this is what we're looking at. And what that really means, if you want to skip the red step and simply go, what I've got is x squared, totally fine. That means you're really doing well in understanding this. So I'll just keep on going through these fractions and get them all reduced. So 6 over 4, how about 3 over 2? Okay. And then there are more x's upstairs, so we only have 1 left over. Upstairs looks like that. So the next term you might write is minus, remember this from 1.5? You can either write it as 3x over 2 or 3 over 2 times x. I'll just write 3x over 2. That's fine. Keep going. 4 goes into 12, 3. There's a 1, so you have a 3 and a 1. Look at the x's this time, completely canceling. So actually, all you have here is plus 3. And last term, of course, 4 goes into 8 2 times, so 2 over 1. And this time the x's downstairs win. You've got an x. So you might say that the answer here is 2 over x, minus 2 over x. And that looks good. This is what we want you to be able to do on monomial division. So I'm going to stop the recorder now, and set up to make the next tape. Okay, so that's it for this one.